Assalamualaikum and hi all. We are still in chapter 4, but this time it is the new subtopic. 4.3 Inverse Matrices. At the end of this lesson, you should be able to compute the inverse of a non-singular matrix using 1. Adjoint matrix and 2. Elimination method. So what does it mean by a non-singular matrix? If the determinant of a matrix, let's say matrix A, is a non-zero, which is not equal to 0, so then the matrix has an inverse. If the determinant of matrix is equal to 0, so this matrix is called a singular matrix, which means we cannot find the inverse of the matrix. Okay, so the matrix have no inverse. So we would like to find the inverse of matrix. So there are 3 methods actually. Okay, the first one is an adjoint method. Okay, so we are going to find the adjoint matrix so that the inverse of matrix A is equals to 1 over determinant of A multiplied by adjoint of A. Okay, second method is by using property of AB equals to KI. And the final method to find the inverse matrix is by using elementary row operations known as ERO. So there are certain rules that you need to follow for this method, and we are going to look at it later. Let's try the first method using example of 8. Okay, part A, find the inverse of matrix A, which is a 2 by 2 matrix. Okay, remember the formula for adjoint method is 1 over determinant of A multiplied by adjoint of A. That means the first thing that you need to find is the determinant of A. So determinant of A is AD minus BC. Okay, so this is your A, B, C, D. So A multiplied by D is 12 minus with B multiplied by C is 5, and we get the result of determinant is 7. Okay, so the next thing that we need to do is to find the adjoint matrix. Okay, so remember that adjoint matrix is equals to the cofactor transpose. That means we are going to find the cofactor of this 2 by 2 matrix. Okay, so for cofactor, remember the sign is plus, negative, negative, and positive. So for C11, we delete the first row and the first column, and we get the value of 4. So 4 here, okay, and next for C12, so delete the first row, second column, and we get the value of 5. But since the sign is negative, so it will be negative of 5. Okay, and then we are going to repeat the same steps. Delete second row, first column, we get the value of 1, which is negative 1 because the sign is negative. And lastly, second row, second column, we get the value of 3. Okay, so we already get the value of the cofactor, and now we are going to find the value of the adjoint. So adjoint is cofactor transpose. Okay, remember you need to write the capital T up here. Okay, and we transpose it. The first row becomes the first column. For negative 5, negative 1, negative 1, 3 will be the second column. Okay, so that is the value for the adjoint. So we have already found the value of determinant and adjoint. Now we can find the inverse of matrix A. So 1 over determinant multiplied by the adjoint of matrix. Okay, And the final answer for this one will be 4 over 7, negative 1 over 7, negative 5 over 7, and 3 over 7. So this will be the final answer for the inverse of matrix A. So for part B, so the same steps. First, we find the determinant. Okay. Second, we find the adjoint matrix by transpose our cofactor matrix. And third is we substitute the value of determinant and the adjoint of A using this formula. Okay. Now, so to find the determinant for matrix B, okay, so for 3 by 3 matrix, we are going to use expansion of cofactor. Okay, I would like to choose the third row to find our determinant. Okay, and the sign is positive, negative, positive. Okay, so positive of negative 2. And then our minor is we delete this third row and the first column, and we have 3, 2, 2, 2. Okay, and then minus with our element here is negative 1 multiplied by the minor of delete the third row, delete the second column, and we get 1, 2, 0, 2. Okay, so lastly, which is plus 0. So I don't need to write that one. Okay, and next we calculate the values. Okay, next is we're going to find the cofactor so that we can get the value of the adjoint matrix. So this is our cofactor. Next is we find the adjoint of matrix B. Okay, now we already have the value of determinant. We already have the value of the adjoint matrix B. And now we can substitute into the formula. So B inverse will be equals to 1 over determinant, which is negative 2, multiplied by the adjoint matrix. And finally, our answer will be negative 1, 1, negative 1, 2, negative 2, 1, negative 2, 5 over 2, and negative 1. Okay, so this will be our final answer. So until then, see you on the next video. Thank you and bye-bye.